level. After reviewing this video, you'll be able to identify an atom based on electron configuration or determine the electron configuration of a neutral atom.
B-O-C-A-B-U-L-A-R-Y.
Vocabulary.
Principal energy levels. There are 7 principal energy levels. And coincidentally, there are 7 rows on the periodic table. So just think of principal energy levels as the rings around the nucleus. The first ring represents the first row on the periodic table. The second ring represents the second row on the periodic table, so on and so forth. So with the example, we have our nucleus in the center, and then we have that first ring, which is known as our principal energy level. And then the outside ring is also known as the principal energy level. Orbitals. And that's just the areas of probability of finding an electron. Did you know electrons were discovered by physicist J.J. Thomson in 1897 when using a device called the cathode ray tube? And eventually what happened is those cathode ray tubes were used in producing the images on the TV. Levels of the atom. Again, there are 7 levels, or 7 principal energy levels. So again, think rows of periodic table. Now, what we're learning about is the sublevels, and they're designated with letters found in each energy level. The number of sublevels is equal to the number of energy levels. So therefore, if we on our 4th energy level, we have 4 sublevels. So the sublevels are designated with the letters S, P, D, and F. So energy level number 1 has 1 sublevel, 1s. Energy level 2 has 2 sublevels, 2s and 2p. Energy level 3 has 3 sublevels, 3s, 3p, and 3d. And energy level 4 has 4 sublevels, 4s, 4p, 4d, and 4f. Writing an electron configuration. To write a configuration, you're going to need 3 things. The first one, the principal energy level. In this case, it's going to be the 1, so that tells us we're in the first principal energy level, or the first ring. The second thing you'll need is the sublevel, so that's your S, your P, your D, your F. And that in this case will be the S. And then the last thing you need is the number of electrons, or the exponent. In this case, we have an exponent of 2, so it tells us we have 2 electrons in the S sublevel, which is the first principal energy level. How to determine electron configuration based on an element. So we're going to use the element carbon. First, we need to figure out how many electrons carbon has. And so how do we find the number of electrons? That's right! Look for the atomic number! Which for carbon is... That's right! 6! So there should be 6 electrons. So, we go to this little configuration chart. Carbon has 6 electrons, so we need to move 6 spaces. So 1, 2, 3, 4, 5, 6. And if you look at the real the periodic table, you'll see the spot that we're at would be carbon. And so our answer for carbon is, well, we went over 1s twice, we would have 1s2. We went over 2s twice, so we have 2s2. And then we only went 2 in the 2p, so we'd end up with 2p2. So the answer for carbon is 1s2, 2s2, 2p2. Next example, let's try an electron configuration for calcium. So we need to find calcium on the periodic table. How many electrons are there? So remember, you need to first look for the atomic number, which for calcium is 20. So, since we have 20 protons, that's going to equal 20 electrons. And remember, that's for a neutral atom. So, now that we know we have 20 electrons, we'll have to move 20 spaces in order to get our correct electron configuration. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So now we just count up what we've gone over. So in this case, we've gone through two 1s's, so 1s2. We've gone over two 2s's, so we write 2s2. We went over how many 2p's? That's right, 6. So 2p6. How many 3s's have we gone over? That's right. So we'd write 3s2. Then how many 3p's did we go over? That's right, 3p6. And then the last but not least, the 4s would be 4s2. So we would write it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So now let's work the opposite direction. Now we're given the electron configuration and we need to find the element. So we have two options of doing this. We can, one, count up the exponents and move that many spaces, because the exponents is the number of electrons. And so if we add 2 plus 2 plus 6 plus 2 plus 4, we get an answer of 16. Good. And then the other option is just moving on the chart, and we'd move to the 3p4 spot. So let's move 16 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so we'll be left with S, which is also, that's right, what is it? Yes! Sulfur!